guys reason well. So,
welcome to NatureMetrics.
yes, absolutely keen to see a bit more about all the wonderful things we're doing.
Yes, I think first of all, this is our sampling station.
Good. Morning, everyone.
Morning. So I'm going to introduce you to our founder.
Good morning. Lovely to see you again.
Yeah,
welcome.
It's brilliant. Guys, lovely to see you all. Are you all different schools?
Yeah. And I think we're going to all try and take an eDNA sample together.
So we can see how it actually works.
So it's all here. So yeah, these are our experts, and we're going to walk through it all together. So if you want to come around here.
Water not looking back,
so the first thing that we need to do is we're going to put gloves on. Gloves. Why are gloves important, guys?
So the DNA that we have on our hands.
Then we end up finding tuna in our DNA sample. This has happened in real life, and we've had to go back and find out what people ate for lunch and rule it out.
Good
so the gloves are very the outside of them.
I'm sure we know.
And then if everybody would like to take a syringe. And Manny as well.
Yeah, nice to see you. Yeah, good. I gather you're a science teacher.
Science technician.
Science technician. You can explain what's going to happen today as well. Because these guys are giving you the technical one. You can actually break it down and make it simple, so you understand the process.
Absolutely. Yeah. There's one for you, sir. You got and you need a syringe as well.
What size are these syringes?
Yes. It's huge. Extra. We're only going to do a couple of syringes this time. So this is built where we get to catch all of the DNA. So it's actually a super simple process.
You got to practice.
Okay. And pull up some water in the pot. Hold on, let me get out of the way. So.
How much do you take in?
Like half.
Half? Okay. Half.
Okay. Good. And then we'll do one practice one. So it screws on this way round.
Like that?
Yeah, like that. There we go. And then who wants to demonstrate? Maybe you guys can all demonstrate at once how we a little bit in case there's any air.
Okay, we don't.
And then the question is where are we going to squirt the water? Do you think
I think we should all aim that way. That's a great idea.
So we need okay.
And you just literally squeeze it.
And just have it helps better if you have the palm of your hand on the end. That's it. Is everybody ready?
Ready.
Okay. 3, 2, 1. Squirt. Oh! Yes!
Oh, nearly! So nearly!
If you've got it's actually easier. And what I'm going to suggest is if everybody wants to stand back a little bit because we're getting better at the
It's the best day of my life. It's great fun.
I would actually fill it. Try and put it. That's it. Fill it all the way up to the top.
All the way.
Yeah, or almost all the way. There we go. So you get a bit more power, and then more and more DNA each time. So what I'm going to suggest, if you've got sort of big air bubble in your syringe, if you can hold before you put your filter on, just hold the syringe up and just push the air bubble out because that actually makes it harder to do. There we go, and then we can pop it back on again. And this will make it much easier to get
fully
a
loaded,
good
that
squirt.
one.
Okay.
That looks very impressive.
Right. Is everybody free? Are you ready?
So you make sure your filter's on, otherwise it's going to fly off.
Filter's on.
Yeah.
Okay. 2, 3. Squirt! Go
on! Won't quite make it.
It'll do it! We're get started.
Is this a technical process in the lab as well? You guys end up being soaked most of the time.
We try to do all our squirting outside. Okay, should we try one more? Squirt from halfway. And when you start squirting, put all your effort into it, yeah?
Not too much.
I just have images of you guys having like some water balloon
Yeah,
fights.
it's so much fun. On a 3, go!
Go.
Yes!
Oh!
Brilliant. Good effort, everybody. Okay, so now we're going to take our filters off the syringes.
Yep.
And if you look at your hand and little particles of sediment and things like that that are caught inside. And that's got, actually it's the DNA, so often we come and we think, right, we're going to get DNA of fish and things, but actually in there you've got the DNA of everything, from the bacteria and the tiny little microorganisms all the way up to the fish and even the birds that have been flying around and some of the wildlife in the area.
What is it?
Slow metabolisms and are not slimy, they give off very little DNA.
Algae, plankton.
No, yeah, they do. Everything has DNA. So we get amazing data on algae and plankton, and they can really show sort of how the overall ecosystem is changing. We just did an amazing project through the Arctic, actually, looking at captured in this
Tiny little disc.
filter, tiny little
How clever is
disc,
that?
and then that's the only thing that has to be sent back to the lab. So it's super simple to do. What I'm going to do is actually, because we're a little bit tight on time, so I'm just going to demonstrate this with just one of the filters. So, because water makes the DNA break down, so we have to take that out to make it stable. A bit of a squirt, and then in here there is just this little tube of preservative solution, and we just screw that onto there. Squeeze it in, and this is really just made of things like solid. Yeah, exactly. So it's got quite helps to have a friend in the field. So it sometimes foams a little bit. And that is ready to come back to the lab. Sometimes it's the other side of the world, but today it's just around the corner.
Should we leave these ones here?
We can leave these ones here, and then I think we're going to go and walk.
I need to give this to somebody trusted. Good morning. Can I give you that? Absolutely. Fantastic.
Jeff.
Okay. Yeah. Oh, fantastic. I'm an honorary member of staff. Yeah. Good stuff. Yeah.
We're going to take you through the first steps of how we extract the DNA from the filter. And we're better.
So we set up the mini extraction of our PCR hood. We'll do kind of a simplified version of what we normally do to simplify, kind of show you our extraction process. And then we'll do a PCR setup.
As long as you're not coming in with it on my nose.
No swabs in here, don't worry. Just this nice filter sample.
Yeah, perfect. Do that. It was great because the children really understood what was going on under it. They really kind of engaged in it and could follow it. That's what they like about this technology. It's not too complicated. You can understand it, and it's part of the role in that is going to be really crucial for you guys. But it's kind of easy to understand. You don't know you can have science to get around it.
Absolutely. I think that's one of the things that everybody
Yeah.
can use it from when I'm
Good.
very good. You've got your own. Yep. So if you'd like to take a seat, let me know if you need questions. So what you have in front of you are, like you took this morning, all those have our DNA trapped inside the filter membrane. So we want to expel them from those filters. So we have a selection of syringes
Yep.
to your left-hand side. And what we'll do is we'll expel our filters into the yellow wrap rag into those tubes. So if you're happy, I'll talk you through the process and you get to do it.
One per.
One per filter, absolutely. So if I get you just to open up tube 1 first in the hood, in the yellow wrap,
And the other.
and then we will, if you've got the syringe down, just for a moment. Yeah. Yeah, we'll lift up that filter and turn it upside down. And then we're going to unscrew that little cap there. Perfect. And we'll now transfer that into our tube. So just carefully take it over and then implant it again.
Literally just.
Straight into the tube.
Yeah.
That's fine if you just leave it in that tube.
Leave it.
Yeah. Okay. And then we're going to unscrew that red dot cap. You can attach your syringe to the top. It just has a light screw mechanism on there. Lovely. And then if you just slowly expel the lysate with the syringe into that tube.
What am I putting in there? Is that?
It's just air pressure, so it's pressurising the filter to release the DNA that you've trapped inside the filter during sampling.
There are trade secrets.
Then we can place both of those together directly into the clear bin to your left. Lovely. And then we close that tube. And we do the same thing with the other two filters. They're quite stiff, those tubes, I apologise.
Okay, two.
So we flip it upside down.
So Becky, normally how many can a lab tech do in a session?
We have about 23 samples done in a session, and that can take up to assess, but we're simplifying this down so it only takes about 5 to 10 minutes.
You're giving a simple version.
Yeah.
Good.
Yeah.
It's always sensible. And this guarantees you get all the sample out.
Yes, absolutely. That filter, you'll just want a good quality DNA that's been filtered through that membrane.
Not much water comes out, is there?
No, we've only applied a small amount just in those filters for today,
Okay.
but in your sampling, the normal sample ones, you'll have a much higher quantity that gets released.
That goes in.
So you're going to invert it,
That's
take the lower lock cap off, and then flip it over again.
But we don't want too large a volume because we want the DNA to be concentrated, so that when you put it into the next step, you've got a decent number of molecules within that small volume of liquid. And the more you scale, the tinier the reactions get. So we'll move from single tubes to plates that have 96 wells, and then we'll scale to plates that have 384, and then more than 1,000. So as we get bigger, everything gets much smaller.
Okay, guys, that's it. There should be 2 sets.
Just that. Should I read it?
Yes, sorry, that's
Tiny
tiny.
item.
Yeah, absolutely tiny.
Both of
No
these?
pressure.
Both ones?
Yes,
One there.
Exactly. Somebody to look at soil health so you can choose the sample, the grouping that you want to have more information about, and then that region within it is unique to a species, and that's what we sequence. This is our post-PCR
Morning, everyone.
lab. So
This is the cheery lot. They're all smiling.
yes, they're very
The others lot were very serious, very hard at work. These guys are a bit cheery. So, what are you, this is PCR, is
yeah,
it?
so this is where we're setting up for the final bit of the sequencing. So they're tagging each of the samples, and then they're supplying 150 samples into one tube.
She's doing like 7 or 8 in one go.
Yes, she does. She's got an 8-channel
You've got an
multi-purpose.
8-channel one. No, I did one, I was only allowed 1 channel. I'm not trusted with an 8-channel.
You can now buy one with 96 tips on it. You can
Each
sound
one,
very careful.
yeah.
But we've got some robots on the right, so we can automate parts of the process, and it saves, so you can do probably the work of 4 people in half the time with those robots. So we're gradually introducing automation, making sure that it's just as good as somebody doing it by hand. So the final stage is to sequence the DNA from the samples.
Right.
But, so we don't go in it.
This is where we find out there's an alligator inside the pot.
Yeah.
Isn't there?
To be able to see the sequencing machines at the end, just say the final stage.
Them and spinning them and sticking them on the machines that look like printers, and then magic happens.
Because I visited the Oxford Nanopore people.
Oh yeah.
So that's obviously a luminous space, isn't it? So
Yeah, that's the newer
that whole
technology.
sequencing is just going, that's
Absolutely,
brilliant,
the cost
isn't it?
crash of sequencing has just opened up the whole world to, so this is the flow cell that the final colourless liquid goes onto with the sequencing machine. You basically get a text file with 30 million lines of A's, T's, C's and G's, which obviously doesn't mean anything to anyone. So then there's the sort of real magic bit that happens in the data processing pipeline that takes these sequences and matches them against the known sequences for different species.
So is each one of those lines, is that an individual species? Of some sort?
It's an individual DNA molecule,
So obviously this one's got a lot of letters versus that one.
Yeah,
What's the relevance of that?
Great question. So when they come off the sequencer, there's just a lot of sort of natural variation in the way each strand has sequenced. And so the first thing that happens in the pipeline, the same length to exactly the same region of DNA. So then you can line them all up and process them together. So yeah, we've got a team of absolutely brilliant people who do that. The best monitored ponds in the world because we use them for all our R&D. But you get, so this platform basically, the first thing is just to try and bring it to life so we can see what we've found.
So the smooth newt is found in the pond?
Smooth newt is found in the pond, yeah.
Is that quite a common newt?
It's more common than the great crested newt, which is the more protected one. But they're just such cool animals, actually.
Yeah.
You don't see them very often.
No,
So
and vulnerable, aren't they? I mean, newts, they have the habitat quite right for them.
yeah, they're generally they're quite set. Look at your environment in a completely different way after you've seen it. So you've got a lot of fish in here.
And out of interest, your DNA bank,
Mm.
how did you come about that? Because presumably that must be evolving the whole time as we
All
learn
the
more
time.
new species and all sorts.
All the time. So we mostly use publicly available reference databases. So basically anytime anyone does research and sequences DNA, when they publish it, they have to submit their sequences to a sort of a public bank. Europe, basically everything gets a good species match. If you're working on freshwater fish in West Africa, only say 25% of those will get a species name, but you'll still have all of the other species, and it will just say, this is a species in this family of fish.
Right.
Still look at the freshwater insects, which are really important as indicators of ecosystem health and condition and pollution and things. So that's sort of what we might expect to have found in the filter that you just collected now.
Literally no seagull or no other sort of
Not,
aquatic bird.
yeah, not in this one. So I think there's a heron here.
Yeah.
We've got
No swan, no duck.
coots and
yeah,
things.
exactly.
Quite often we do get ducks, but yeah, quite a few fish and things. So it all looks as expected. There's no whales or tunas or anything.
Nothing hiding in there.
Yeah. But then one we really wanted to show you is this project, which you might recognise because it's one of our fellow Earthshots.
Is this something, did this come back from the Earthshot, or were you already working
We
in
were
partnership?
already working in partnership with them, so it was really amazing to then sort of find we were both in the so it's up here in the west of Kazakhstan, and what's cool here is the first thing on the list is the tiger, which is great because they actually don't know much about where they go during the year when they're not doing the aerial surveys, so just sort of helping to fill in some of those gaps.
Interesting if that's going to change now with the success they've had there.
Yeah.
When that gets downgraded a bit or not.
Yeah, no, that would be amazing.
Yeah.
We have had examples.
You guys are now providing that kind of
Exactly.
that background solidity that this is real.
Yeah, yeah. And often you find these species when you're looking for something else and they just pop up in the data set and it's all really valuable data. So you can sort of then see where the...
This is where I ask you a wonderful question that everyone's going to want to know. Does this mean you can find the Loch Ness Monster?
Oh, do you know what?
If you
People
do
have
DNA
tried.
Loch Ness, can you find it?
People have tried.
Have they?
Annoyingly, people came from New Zealand to try that.
Oh, okay.
And they took about 500 eDNA. All they needed to find is one bit of unidentified reptile DNA.
Yeah.
They could have had a story, but yeah, no. We've been asked to try and find Yeti and Bigfoot and all sorts. It comes up. But yeah, so you can sort of see where, actually it's easier to see on the satellite imagery. You can see where, but if you look at sort of here, you can see species richness. What's quite interesting is actually the areas where the saiga is found are the areas that have fewer species overall. So you might look at that and go, they're less important areas because they've got fewer species, but actually there's really important species in there. So you can sort of look at it.
Invasive species are travelling.
Yes.
And but this is going to be a good. You'll be able to build hopefully a bit of a database on invasive species because that's something I think no one really has a grip of what's going on there.
Yeah, and the impact of invasive species to the economy is absolutely huge, and they cause so much disruption. So particularly we do quite a lot of work in ports and looking at shipping, and that's one of the sort of classic ways that the invasive species arrive. So if you can catch it early at the port, then you can do something. It's a lot of fun.
Fantastic, yeah. So much learning. It's amazing. Got huge potential.
We do have.
Oh, thank you very much.
Take home. We've got both soil and water kits in there as well.
Excellent.
So you can.
Now you've shown me how to do it. I can show you how to do it.
Give them a go. Hopefully, the practice today has helped.
Yeah, I'll let you know what I find.
And then send them back to us, and we'll dissect your concepts.
That's very cool. See what we do. That sounds good. Morning, everyone. taught just about double my science knowledge than I had before I walked in the door. So it's very impressive. It's a very lovely school children who are equally as excited and willing to get involved in it all.
I heard you nearly got squirted.
Not me, that lot did. But it wasn't. But it's been, I mean, some of you know this better than I do already, eDNA. This is new to me from Earthshot. So it's been really interesting. I know, John, you've invested in it already.
We have indeed.
How has that come about, and what have you seen that you particularly like for your side of things?
Well, for us, we invested, just climate as the name suggests, we invest in just climate. But there's also of climate. But we also concluded very quickly that we couldn't invest in climate if we weren't also solving the nature crisis. And so finding and creating a business to invest in that. And as we looked around for the tools and the technologies that were going to enable foodland and agriculture to transition to a more sustainable, we can bring this technology to much wider.
And what particularly do you see about it that you think is of use? Is it getting a database? Is it understanding more data around certain areas that helps inform our decision making?
I think getting the data is going to be the core, but as you probably saw this morning, the ease and the ability to roll this out and to avoid, one of the things I was involved in before was, for example, offshore wind. And so when you go to do an environmental impact study on offshore wind, the first thing you do is go and dig a bit of the seabed up to try and find out what's down there.